Welcome to our introduction to neural networks, a cornerstone of modern artificial intelligence. Let's start with the basics. What exactly are neural networks? Neural networks, or NNs, are computational models directly inspired by the structure and function of the human brain. The core components of any neural network are neurons, the connections between them, and the arrangement into layers. Before a network can learn, the data must be properly represented. Neural networks can handle both numerical and categorical data types, each requiring a specific approach. Pre-processing is crucial. Numerical data often needs scaling, while categorical data requires encoding to be machine-readable. Next, let's understand how these data representations move through the network layers. Neural networks are structured with an input layer, multiple hidden layers, and a final output layer. Hidden layers perform complex computations to extract features, while the output layer delivers the final prediction or output. Activation functions are essential for introducing nonlinearity, which allows the network to learn complex patterns. The primary purpose of activation functions is to introduce nonlinearities, enabling the network to model complex, real-world data. Some common activation functions you'll encounter include sigmoid, rectified linear unit, ReLU, and TON. The network's parameters, weights, and biases are adjusted during training. Regularization techniques like dropout help prevent the common issue of overfitting. Once the model is trained, rigorous evaluation is needed to ensure performance. Key metrics like accuracy, precision, recall, and F1 score are used to evaluate the model's scoring and performance. To optimize performance, hyperparameters are tuned using techniques like grid search, random search, or Bayesian optimization. Neural networks have vast applications, transforming numerous industries globally. From image recognition and natural language processing to personalized recommendation systems, NNs are driving innovation. The versatility of neural networks makes them invaluable tools for solving complex real-world problems and reshaping our interaction with technology. Welcome to Deep Learning with H2O, a complete workflow. We'll guide you through building scalable, intelligent models. Let's start with the basics. What is deep learning, and how does it relate to the human brain? Deep learning is a powerful technique where machines learn from data using neural networks, systems inspired by the human brain. Deep learning excels because it handles complex patterns, large data sets, and delivers state-of-the-art results, especially in image, text, and prediction tasks. Now, let's introduce the tool that will make deep learning accessible, H2O. H2O is an open-source distributed machine learning platform. It's fast, scalable, and supports deep learning with user-friendly tools. Getting started is easy. Install with pip install H2O, then initialize your environment with h2o.init. Before training, we need to prepare and structure our data correctly for H2O. Load your raw data into an H2O frame object using H2O frame, pandas_df. This converts it into H2O's native format. Next, split your dataset into training and test sets using the split_frame function to ensure unbiased model evaluation. Now, let's move on to the exciting part, building our deep learning model using H2O. We use the H2O Deep Learning Estimator to create our model. This is the core class for deep neural networks in H2O. When configuring the model, define key parameters such as the hidden layers, the number of epochs, and a unique model ID for tracking. To train effectively, there are a few important concepts you need to understand. An epoch is one complete pass through the entire training dataset. More epochs generally lead to more learning, but watch out for overfitting. Checkpoints save your model's progress. This is crucial for resuming interrupted training or leveraging transfer learning by initializing a new model from an existing one. Once training is complete, we must evaluate performance and use the model to make new predictions. Evaluate your model using performance metrics like mean squared error, root mean squared error, and R-squared to assess its accuracy. Use model.predict test to generate predictions. You can then convert the results to a pandas data frame and compare predicted values against actuals. Deep learning is being used everywhere. Let's look at some real-world application examples. We'll explore datasets like California housing and NBA player statistics to demonstrate the complete workflow from data loading to prediction in our notebook demos. Deep learning with H2O empowers you to build scalable, intelligent models. Explore further and unlock new possibilities in AI and machine learning.